Hey everyone, today I want to talk about my 12 favorite CTF tools. If you've been playing CTFs for a while, I don't think any of these tools should be controversial. If you think I'm missing anything obvious, let me know in the comments. But if you're new to CTFs or don't recognize the tools, hopefully I can or at least present a somewhat decent argument as to why you should check them out. I'm also going to provide some tips and tricks and stuff like that related to the tools and cool features I think the tool has. And with that, let's get started. So the first tool I want to talk about is Docker. Docker is an amazing tool. It has a lot of different use cases. I'm going to talk about 3 different ways I use Docker. The first one is when I want to match what a remote system looks like. So if you watched some of my videos, specifically my pwn videos, you probably see that I use it to copy out libc. So if I know that, let's say docker run interactive tag Ubuntu 2204. So if I know that the challenge infrastructure is using Ubuntu 2204, I can just go in here and then I can do etc lib x86 libc, and here is the libc for Ubuntu 2204. If I knew they're using 2004 or 1604, using this method, or if they give you a specific hash, I can just copy out the libc, and I don't have to like search online for it. Super useful. But if instead they were using, let's say, Debian, I can instantly drop into a Debian box. I can see what the libraries look like, how things are configured. Another one is sometimes we get PyGL challenges. So you need a very specific version of Python. So let's say they're using Python 3.8.16. Instead of like going through and mucking up my remote system, or sorry, my host system, I can just jump into a Docker container for that very specific version of Python. And this, I feel like all the time, since most CTFs are running on some sort of Docker or Kubernetes system, they're going to have a very specific version they're using, and if you can match that remote system, it just makes exploit development so much easier. And there's also Docker containers for everything. So like the other day I needed a Docker container for angr because I was having trouble with PyPy in my local system. I just jumped into a container. Volatility is a pain to install locally, so volatility, I used one from BlackRock or something like that. Oh, Blacktop is the one I've been using. It just works. I don't have to install volatility locally, and you can do that for volatility 2 or 3, which is a whole different story. Just super useful. Oh, another good example is HTTPD. So I was doing a web challenge where there was a PHP LFI. So PHP, they store their session variables in these files called the sesh_files, and there can be in different places all over the system. But depending on the version, they might be installed in different directories. So I knew roughly what Docker container the challenge was using, and so I was able just to jump to that box, read the Apache config, see where those PHP session variables are being saved, and then from there I don't have to do as much guessing and checking. So super useful. And like I said, you just spawn the container, you run it, and it's just set for you. So that's the use case number 1, is just kind of getting a feel for what the remote system looks like, the library versions, config files, the defaults, how things are aligned. The second use case is one-off tools. So there was a CTF last weekend where there was a challenge related to ESP32, and I had to install a QEMU related to that so I could run it. Instead of having to install that on my Mac, which would have been probably a pain, I can just boot up a Ubuntu machine. And I'll talk about make files in a little bit, but this is how easy it is. I just do make Ubuntu, and then from there I have a little playground where I can install these one-off tools, and if I mess anything up or whatever, I just clean up and I'm gone, and so I don't have to worry about it. It doesn't take up space, it's not going to clobber with anything. It's like a fresh Ubuntu box. Super useful, and like I said, I use it just whenever I need to install some weird tool. It's not for security protections, because there's a lot of Docker escapes and stuff. It's more of just like not negligence, but just me being a dum-dum and messing something up. And then the last use case is pretty much this right here, is I store all my tools in Docker too. So whenever I need Ubuntu, which is where most of my tools are installed, so I have this image called Ubuntu Pwner, which I'll show what it looks like in a second, but I just run this command and all of my tools are pre-installed. My config's in here, like I use tmux. I have so my tmux config is automatically loaded. I update to the latest version of all my tools, pwndbg. I'm going to talk about that one a little bit later. It just all exists within these Docker containers. And I have them for different versions of Ubuntu. I have a Debian one. I have a forensics one. I use one for Sage when I do crypto challenges. So all my tools are already loaded, and I have a clean environment whenever I want. And if something happens or if I mess it up, I just delete that container and I create a new one. Super useful. And so like I said, you can create your own Docker containers. So this is a Docker file. And so you can base it off an image. Like I said, I base it off a bunch of different images depending on what type of challenge I'm working on. If at the start of a CTF, sometimes they give you a hash. So it'll be, like some long hash value. I'll go to my Docker files, specifically the one that's closest to that hash. So if I know it's like a 22 or 20, usually it's 2004, I'll change my 2004 box. I'll put in that hash and then I'll just rebuild the Docker container. And so I know that as I'm building my exploits locally, it's going to be on the exact same system as remote. And these are the tools I install. I have a couple of custom tools I took out, but this is like pretty much everything. If you've never seen a Docker file, they're really not too bad. So like I said, you say from base image. I forget what this is for. I've had it in forever. Maybe I don't even need it anymore. But here's I'm just installing a bunch of tools. I'll be talking about a bunch of these in a second. Here I'm just installing pwndbg. Here I'm installing pwn-init, one gadget, angr, ipython, and then I set the working directory, and then this is the command you execute normally. And then once you do that, you do docker build tag, give it a name. I call mine Ubuntu Pwner, but you can call it whatever you want. And then period. It'll automatically start building it. And from then on, whenever you want to use it, you just run a command like this. So this is docker run interactive. This is the tag, which actually, maybe I should move it down here. This is the actual tag. This says remove the image. Remove the container volume, I should say, I think. When you're done, this is how you do volume mounting. So I take the current working directory, which is this, and I map it to the chow folder within the Docker container. So this will copy over the binary or anything I'm working on into the chow folder within the Docker container. And so normally what happens is I'll be writing my solve script here. So, I'll be typing along, and that'll automatically get copied over to here. So actually, do I have? Where is this? Let's just make a new file. So we'll say hello .text, and we'll put this in CTF Tools is where I am. And we'll just put a bunch of text in here. And so now there should be a hello.txt. And so you can see this is my host machine, and this is the Docker container. So everything just instantly transfers if you're using that /v for volume mounting. So super useful. I type up my exploit scripts here, and then I can run it in whatever box I want. Yeah. So the next tool I want to talk about is make and make files. This is not specific to CTFs. Make is actually a build tool. And so basically it's just these labels followed by commands. And I use it just as a way to organize all the different tools. As I play more and more CTFs, I have to remember more and more tools and their syntax, and I forget all that stuff. And I'm just lazy. Like, I don't want to have to type this out every single time. So I use make files to just kind of organize everything and as a form of documentation. Like a good example is FUF, which is a really cool tool for brute forcing stuff on the web. It's kind of like a web fuzzer, but I never remember the syntax. And instead of having to remember it, I have a make file for web challenges where I have the FUF commands for doing like a dir bus and for subdomain brute forcing. That way I just don't have to think, because I don't like thinking. But like I said, it's just a series of labels and commands. So now instead of having to type out this giant command, you can just do make docker. Why is it being weird? Oh, I'm already in a Docker container. Oops. Make docker demo, and it runs. Like I said, super useful. So at the start of every challenge, I have a make file for each of the categories. I just copy it over, and it works. One thing, so a lot of the times, like, you'll need to run commands on that specific challenge. And so to kind of make this a little bit easier, what I do is in each of those make files that I copy over, so I just have a directory. I actually have a tool that does this for me, but I just copy over the make file, and so I put anything that needs to be replaced with this uppercase target, and then I have this, and so you can see this is checksec, super common pwn tool. I'll talk about it a little bit later. So it's going to run checksec within Ubuntu, but it needs the file to run it against, and so I've created this t command that I use. So I do make t is equal to, let's say, the challenge was called chow file. I run this, so make t. This is the t command, and then I give an argument, t is equal to chow file. It's a little bit weird syntax, but it works. Oh, oops. Keep forgetting I'm in so I was already in a container. I'm doing things a little bit backwards. Make t equals chow file, and so now if you come back here, you can see this no longer says target, it says chow file. And so like for the web challenges, I'll do that with URLs. So it'll just instantly replace all the URLs. For the binary challenges, the pwn challenges, like I'll replace the binary name. And so you can see here it's updated. This is my ghidra auto script I got off of GitHub. Sorry, not mine. This is the one I use. I'll put a link for this. It's super useful. I hate waiting for ghidra. But you can see it just automatically changes it. And so now when I want, I can just do make ghidra and ghidra will pop off. The next tool I called Visual Studio Code, but really I just mean any editor, and also organizing your files using an editor. So I think any editor works if you're not used to IDEs or very new to CTFs and development. I think Visual Studio Code is a great editor. I've used Emacs, Vim, they're all great. Any of them work. It really doesn't matter, but Visual Studio Code, it's very well tested. It has extensions for everything. It's pretty intuitive. The syntax, like I said, it just pretty much works out of the box. There's a couple of things that you should know how to do. One is open up command palette. So I'm on a Mac. I don't know. You'll have to look it up on your if you're not on a Mac. But for me, it's Apple Shift P. And so I can just do a whole bunch of different things like this, like Python select interpreter or whatever. It does a good job of like whatever you need or change language. Super useful. The other super useful tool is global find, which I'll talk about a little bit more in a second. But just being able to search over entire directories for stuff. Again, not really related to CTFs, but just things that are super useful. Another one is just find and replace, and specifically you can do it with regexes, but you don't have to do anything complex. Like a lot of times you'll get like a bunch of numbers in a CTF or something like that, and so you can do /n and then this little regex thing and like a comma, and now it's an array with commas. And so like if you're writing something in Python, maybe there's 1,000 of them and you need to put it into array, you can just do that real quick. There's probably faster ways with like multi-cursors and stuff, but just a bunch of like simple find and replaces. Again, not the coolest tool in the world, but just a tool I use all the time. Related to this, it's not really related to Visual Studio Code, but another thing I think is just so useful is storing previous CTF solve files. So I don't know if you saw that, but I have a command that just, this popen. So I have a tool that I wrote called pwner, just a personal tool, and it takes me to a Visual Studio Code that has a bunch of my previous solve scripts. I'm not always the best about updating these. I should get better, but basically if I solve a challenge and I think it's interesting, it goes into this library of challenges. And then, like I said, I can do a global find, and if I need something, so I guess recently I was looking for some ROP code. Here is a bunch of CTF challenges I've done related to ROPing. This is all code I wrote. So I was looking up a House of 4 SEEP exploit. This was related to some challenge I did a while ago. Again, I'm not going to review previous challenges, but sometimes I just want to copy stuff out. So like the other day I had to do elliptic curve challenge. So instead of having, actually elliptic curve. So here is 2 challenges related to elliptic curves. So I guess I was doing some smooth curve challenge. Again, this code is disgusting. We could change language to Sage, but it doesn't matter. It's not amazing code, but instead of having to copy out, I guess I'm doing the discrete log tech. Instead of having to copy stuff out or like figure it out on Google or read someone else's GitHub, I have my own code here, and I can just change some values and copy it over into whatever challenge I'm doing. So again, as you do more and more CTF challenges, I think it's just super useful to save all of them. And like I said, the more CTF challenges you do, the more of these solve scripts you have, the more tools you learn. And I'd say maybe like a good portion of CTF challenges I do now are like challenges I've already solved before. And so that gives me more time to focus on the fun challenges by just copying over scripts. The next tool I want to talk about is the Python request library. So this isn't a CTF tool. It's just a general Python package, but I think it's just one that's super useful for CTFs. I'm sure if you play CTFs, you already know about this tool. But like I said, it's just a tool for making web requests. I think its tagline is HTTP for humans. Again, it just has a very clean API and makes things very simple. So like if we wanted to download the HTML for some website, so we can do r is equal to request.get. We'll do conrad.io. This is my website. And that should be it. Then we'll do Python 3 solve. And just like that, we have the contents. If it was JSON, you can also ask for the JSON of it. If we needed to get the cookies out, so a common thing is you'll get cookies from one web request and you need to send it to the next web request. So Conrad doesn't return any cookies, but if it did, request, let's actually call this R2. We should be better about doing this stuff, but then we can do just like this, and we can pass the cookies on. Or if we needed a specific header, you can pass headers. If you need to pass JSON, you can do ABCs, 1. If you need to just pass like www form URL encoded data, you can just do it like this, a equals 1. Like I said, just makes anything involving, web scripting super simple. And so, again, one of my favorite tools just because it's reliable, it works well, it's very clean, it's very intuitive. I like using it. So the next tool is very related to request, and it is a webhook site. There's a bunch of these. I specifically use webhook.site, but it doesn't really matter which one you use. I think this one works very well. So it's common that you'll be doing a web challenge where you'll need to exfiltrate like a cookie or something, and so you need an endpoint that is web accessible, because obviously your local machine normally is not accessible. And so this is just a good way to just send data somewhere, and so it'll get your query strings, your post data, your headers, whatever you send it. So here I was doing some challenge. I don't remember what CTF this was, but flag XSS via an open window, and I was able to copy it out as a URL parameter. And so whenever I just need to exfiltrate something, I just use this. Kind of related to this, sometimes you need a more dynamic solution. So maybe you need this server to respond with something. For that case, I use angr. Very simple tool. You just do angr HTTP 8080. And so if I had something listening on my local machine on port 8080, what this tool will do is it's kind of like a middleman, and it'll connect to the server on 8080, and it connects to this remote port, and it just acts as like a little bridge in between them. And so if anyone goes to this website, it's now connecting to 8088 on my machine. I don't have anything running, but if I did, we'd be able to see it. So again, super useful if you need something dynamic. There's also a third case where sometimes things are too slow locally. Like I was doing a CTF that was based in Singapore. I think it was like stack the flags or something like that. And there was a brute forcing challenge. Sometimes there's a third option. Sometimes you have to do this third option where you have to spin up like a virtual machine a little bit closer to Singapore, or if it's a a checksec sort of challenge. And so for that, I used to use EC2, but now I use DigitalOcean. EC2 has been very flaky for me, which has been kind of frustrating. But you just spin up an EC2 over there or something, or a DigitalOcean droplet, and then you can install your web server there. But 3 different tools for exfiltrating data, but most of the time, if I can, I just use webhooks because it's so easy, so reliable. I just like this tool a lot. So the next tool I want to talk about is cyberchef. So it used to be that if I needed to base64 or something, or get an ASCII decoding, or hexify something, either I do it in Python, or I go to Google and I do like base64 encoder. I started using cyberchef maybe a couple months ago, and it's just way better. So let's say what you do is you copy over these recipes into this thing, and so this is 2base64, and here's my input, and so I can say like, hello YouTube, and that'll output it down here. And it's all real time. If I then needed to convert it to hex, I can add it down here, and so this output now gets converted to hex. And there's just a whole bunch of different rules from like encryption. I use it for AES sometimes, like if I just need to decrypt or encrypt something in AES real quick. It supports all the common modes. XORing is also super useful. If I want to look at the entropy of something, sometimes there's like one of those annoying stenography challenges where they give you like a base64 wrapped in something else, there's this magic option that just kind of guesses it, which is pretty fun. If it doesn't work, I use a tool called Cyphy, which doesn't matter. It's just, like I said, there's a whole bunch of different encryptions. Oh, another common one is ROT13 brute forcing. I just saw it. Here it is. And so what this will do is this will do a ROT13 of this and give you all possible permutations. There's also one for XOR brute forcing. XOR brute force. So if you needed to do an XOR brute force, it'll show you all the permutations real quick. Again, this thing just has a lot of different tools built in that make solving this kind of like smaller CTF challenges a lot easier. The next tool is pwntools. So this is a Python library that assists with exploit development, and pwntools does a lot of just great stuff. I'd highly recommend just going over their docs and just at least knowing or being familiar with all the things it does. I'm just going to cover a couple of things that I use a lot, but there's a lot to it. I think probably its biggest or most commonly used tool or like use case is for connecting to remote and local tools and providing a clean interface for communicating with them. So it has like, you'll have to connect to like some netcat port, and you have to like receive data and send data. You can do that with like Python telnet, and you can do it with netcat and printfs and stuff, but using pwntools is just very clean, reliable. It has a lot of good tools for like receive until this specific thing, or bufferings and timeouts. It just works in a very clean and intuitive way. And I mean, this is like the de facto standard, I'm pretty sure, for doing CTF, kind of these exploit developments, and for good reason too. It's an amazing tool. So like I said, I'm going to cover a couple different common use cases that I use it for. But oops, Python 3. I'd highly recommend just reading over the docs, especially if you play a lot of CTFs. There's a lot in there. The first one, a little bit silly, but it has a great XOR implementation. I feel like a lot of CTFs they want you to XOR stuff together, and sometimes it'll be like strings and bytes, and there'll be different offsets, and you need to repeat or something. And instead of having to implement that in Python over and over, or copy over an implementation, the pwn XOR function actually just works great. I'm glad I never have to write that again. But like if you have some string and you need to XOR it against 33 or something, it just works. You can ignore that warning, but I think it wants bytes. There's like this AES bit flipping attack where you need to XOR unset something, then XOR it, and then reset it with something else. And so you can XOR 3 different things together, which is pretty cool. Silly little tool, but super useful. Another one is pwncyclic. I use this in a bunch of my Stack Overflow. So if you watch any of my pwn videos where we do a Stack Overflow, you have to calculate the offset where the Stack Overflow, like where that RIP is on the stack. Pwncyclic just makes it super simple. So you can do pwncyclic 100. So here's 100 characters. And it's in a repeatable pattern. And if you see that your stack is smashed, and this is the thing that actually is now in your RIP or register, you do poke cyclic, is it cyclic find? And we can see KAAA is at offset 40. And so now when I do my, it'll be a pwn.sendLine, then I'll do like A times 40. And then from here, then I can do my whatever I want to set my RIP to. Silly little tool, just makes exploit development much faster. It used to be like I would do like deadbeef A, deadbeef B, deadbeef C, change a little number in there, and then like I try to calculate, or I do like 40 A's and then deadbeef and like see if it populates RIP with that, and then calculate the offset myself. But I don't have to do that anymore. I just use pwncyclic. Super useful. Like I said, probably the most common use case is this like remote local thing. So you can do r is equal to pwn.remote, and you give it some server. I don't have anything running, but if I did, and a port, this isn't going to work because there's nothing listening. But from there, I now have like, I think pwntools calls it a tube. And so then you can just do r.sendLine or r.receive-until, and it just provides a nice interface. And when you're ready, so normally you would run it locally. So you do r is equal to pwn.process. And so let's say I have, my challenge binary. I would do it like this, and at the very end step, when I want to connect against remote, instead of having to change everything, I just keep that R variable the same, and then I can do it on remote. And so, they'll give you some, IP address that is actually not an IP address at all, but, some IP address that you need to connect to and run it against, and you just swap out this line and it works. Super nice. Kind of related to that, when you're developing locally, you need to attach GDB. You can do that yourself, like, it's really not that hard, just GDB attached to the process. But in pwntools, again, it's just a collection of just super useful things. If you watch any of my pwn challenges, you'll see me do this. There's a tool for connecting GDB automatically, and it'll start. You can include GDB commands you want it to execute. So like if you know where the breakpoints are going to be, or if you want to print out the heap, it just does it. Another one is patch. Do I have pwntools? Yeah. Go. So sometimes there'll be. Is this patch sleep? I don't know what that is. Sometimes, like as a anti-debugging trick, binaries will like put in like these sleep statements every once in a while, or sometimes like you'll get a challenge where it'll do like a sleep, and then it'll type out character by character to kind of give that cool terminal effect. It's cool the first time, but like if you have to run the binary like 30 times, it gets really old fast. So pwntools also has ability to patch out assembly out of a binary. And so here I'm loading this binary called elf. I think this is a hack the box challenge. So I print out the symbols. So I load the elf file, pwn.elf. I figure out where that symbols is. I just make sure that I have it correct. And then I'm going to do elf assembly at wherever this address is. Instead of calling sleep, use the assembly instruction for return, and then save that as casino patched. And so now when I run this, instead of calling sleep, it'll just return from that function. Super useful. You can patch it with a whole bunch of stuff. So I use this for any time I need to do some sort of like anti-debugging thing, and it's a super simple script, as you can see. Or if I want, you can also like overwrite stuff. Recently I've been using Binary Ninja for that, for overwriting assembly, but you can do it in pwn-tools too. Specifically, there's a lot of them. Next is ropping. I think we already saw this, but I use just amazing stuff. So here's just some random script. So this is a pwn-tool script. We can see we're doing pwn.rop on the elf, and here, what just so amazing. What I'm saying is, or what I'm telling pwn-tools to do, is figure out the rop payload such that RAX is equal to 1, RDI is equal to file descriptor, RSI is equal to some buffer, and RDX is equal to 7. And it'll generate all the ROP codes, find the addresses, all that stuff for you, and it just works. Like, I mean, just absolutely amazing. And then you can do rop.raw, so just insert some raw thing. So this is the syscall. You can't always do rop syscall address. This doesn't guarantee it has a ret after it, but minor detail. If you're not familiar with all this ROP stuff, don't worry. I have a bunch of other videos. I don't do the best job of explaining what ROP is, but if you want to see examples of what it looks like, there's a whole bunch of videos on the channel. And last is, that's not pwn-tools. That's pwndbg. Yeah, like I said, oh, and then also shellcode. It used to be like, if you want shellcode, you'd search for like, Linux shellcode. And let's see, here we go, shellstorm. And so you would copy out this hex. Thankfully, we don't have to do that anymore. You can just go to pwn-tools, as long as you set the context correctly. So at the very top, when you're using pwn-tools, do I do it here? Yeah, if you do pwn context binary, you set it to this elf, it'll figure out like what type of architecture, if you're using 32 or 64-bit. It kind of knows all that stuff, and so then you can do pwn shellcraft. Again, one of these tools within pwn-tools, and it'll just generate a bunch of different shellcodes for you. So like if you want something specific to like opening and closing files or making a network request or just opening shell, it just has preloaded all the shellcode for doing that. And again, it's very intelligent about what type of architecture you're using, and so it'll generate the correct shellcode for you. I mean, amazing. The next tool I want to talk about is pwndbg. So this is an extension of GDB, and it just makes GDB printier, and it introduces a bunch of very useful tools for exploit development and CTFs. So I made a quick little demo because I want to look at some heap stuff. So it's heapdemo.c. We're going to do 2 mallocs, a string copy. We're going to do free. You can see a double free here, and then we'll do another malloc. And so we're going to jump into an Ubuntu box. We're going to do GCC. We're going to compile. We call it heap something, heap demo. We're doing the -g just to include some debug info, which we'll see in a second. And then we'll do gdb a.out. And then we're going to do a break main and run. Okay, well, let me see how big we can get this without it looking too ugly. Okay, I cut off some of the registers on the top, but trying to make it as big as possible. Anyways, this is the pwndbg interface. If you're new to this, it looks like a lot, but really it's not too bad, and it's amazing. So this is all the registers on the top, and everything's color-coded, which isn't too important, but as you get used to it, it's just very nice in comparison to normal GDB. So we can see what's a stack variable, what's a heap variable, and what's in the code segment. Just to quickly describe those, there's a tool called vmmap. So again, if you're new to this, I'm sure it's a lot, but programs are laid out in memory, and so each process thinks it has like the full RAM space, so gigabytes of RAM dedicated just to itself, and so it lays it out in its own space however it wants. And if there's a thing called address spaceland, a layout randomization, and if that's enabled, things will kind of be all over the place within this giant memory space, and so you can use vmmap to see where they are in that memory space. Hopefully that was an okay description. But anyways, there's the text segment. So this is where your actual executable code is. And so pwndbg includes this vmmap, super useful, that you can use to kind of see where stuff is laid out. So a lot of times, like if you're going to do a ret to win sort of challenge where you need to jump to a known function, you need to figure out where that function is living in memory. And so you can use vmmap to kind of see, okay, well, this is the start of the instructions, and then using another tool like ghidra, which I'll talk about a little bit later, you can use that to find the offset, and you can figure out where specifically you need to jump to. And you can see this is where libc is loaded, also very useful. We can see that the stack is down here, And in a second, the heap isn't created yet because we haven't called malloc, but if we do n for next, we'll do next, and next. If we call vmmap again, technically it exists after the first one. You'll see there's this new segment called heap, and so now we have a heap loaded. Again, super useful tool. Like a lot of times you'll do a libc leak and you'll need to calculate like the offset between your leak and the base of libc. Just running vmmap, then you can copy this out and calculate your offset. There's a lot of useful tools in pwndbg related to, actually before I talk about heap, another thing that's common is you'll need to figure out an address in the global offset table. If you've never done pwn challenges, I'm sure this is a lot, but just know this is useful tools, and eventually once you start doing pwn challenges, this will be very useful. But here's the global offset table entry for free and malloc. We can see full railroad was on for a bunch of 2204, so a little bit hard to overwrite, but I mean impossible to overwrite, but this is where they're located. I think I have some notes. I'm going to talk about heap stuff, but better UI, vmmap, heap, GDB scripts, and global offset table. Okay, cool. The next one is they have a whole bunch of heap tools. So we created in our script, if we scroll up, we did malloc 8, malloc 16, and then we did a string copy to B. So we can do viz heap chunks, and it'll show us what's on the heap. It'll color code it. Absolutely beautiful. And so here's our top chunk. We can see, I forget, they call this like the forest or something. This is, everything going down. There's a whole bunch of stuff that we could allocate. Here is one of our heap elements. It has a size of 20 hex, so 32 bytes, which is this. You can kind of ignore that, but basically these chunks that kind of overlap weird. But anyways, we can see this is where we copied lol nice, and it exists right here into one of our heap chunks. So this is A and this is B. And it's just nice that it visualizes it for you. It makes heap exploit so much easier now that you can print stuff out. And there's a whole bunch of stuff related to this, like if you need to see bins. So if you're doing like a tcache bin attack or something like that, it's nice to see what your bins are pointing to and how they're aligned. If you want to get general information about the heap, see where stuff is or where the arena is, kind of heap specific stuff, but it just prints it all out for you in a nice clean way. It works on a couple different implementations of the heap, which is very nice. And just in general, just makes things so much simpler. Another very useful tool is the search tool. So we copied that lol nice somewhere. Sometimes you need to find an address of something that's pointed to something else, or you want to figure out where a string lives in memory. So you can do type string, and it was lol nice, I think. So we can search for the string lol nice, and we can see it exists in the heap at this address. Super useful tool. You need to search for stuff, and it just works. Sometimes it can be a little bit weird. I think sometimes it doesn't want to search all the segments, or I could be doing something wrong, but sometimes it seems to be a little bit finicky, but for the most part, it works very well. I'm probably just using the tool wrong. For this next tool, I kind of cheated a little bit. I called it pwn-utils. This is actually 3 tools in one, but they're all small tools, so that's my justification. I jumped into a challenge from a previous CTF. This was rutro from LA CTF a couple of weeks ago. Nothing related specifics to this challenge, we just needed a challenge binary. So I'm going to jump into Ubuntu. The first tool is checksec. Checksec, rutro. And so what this tool will do is it'll show you all the compile time protections that were enabled. Again, normally it doesn't look quite this ugly. I'm just making the text very big. Here we go. But we can see what protections are on. This one was called rutro, and it's just kind of joking that railroad is on, which we can see full railroad, so you can't overwrite it. But we can see there's no stack canary. This is non-executable stack, position independent executable. Again, just useful tool for seeing what protections are enabled. And this can kind of guide you for where you're supposed to be looking for bugs, or once you're ready to write an exploit, what type of bugs you have in your arsenal. Like if you know NX is enabled, if it's not enabled, you're probably going to be writing shellcode. If it is enabled, you're probably going to be wrapping or doing some sort of heap exploit. So just very useful tool. I use it at the start of every binary challenge. The next one is OneGadget. When I first found out about this tool, it blew my mind. I could not believe. Oops, we need libc. Libc. Probably starting to copy it over. There it is. So what this tool will do is, it's just mind-blowing that it works. If you jump to this address here within libc, it'll execute this line. So it'll do execcv, so it'll just execute bin shell with this as the environment and something else, the arguments, I think. just so cool. Or if you jump to this line or this line, and it's called one gadget because a lot of the times, like if you overwrite the global offset table, you only get one jump. But using these one gadgets, you only need one jump. Like you don't need to set up any registers. You do need these constraints to be true. So like for this one, you need either the address of RSI to be null or RSI itself to be null. And same for RDX. You do need these constraints to be true, but as long as you can get one of these three to match, you can jump to these just this jumping to the single address, you instantly get shell. Just unbelievable, so cool. And then the last one is ropper. If you can't, use one gadget immediately, or you need to jump around, like sometimes you have to jump around to get like a libc leak first. You do need to know where libc exists. These are the offsets within libc, so you have to know where libc is loaded into memory. But there's another tool called ropper. So we can do oh, I might not have it. Pip install ropper. I keep forgetting to add this to my Docker file. Ropper, I think it's file. And here are all of the ROP gadgets we have available. There's really not that many for this challenge, but we can start looking through and start ropping. This challenge looks a little bit difficult, actually. Yeah, there's not much. But yeah, another super useful tool. Normally when I use it, I use I think it's like this, no color. Yep. Sometimes I should learn how to do everything, but I only want the ones that end in ret. So I grep it on ret, and then I send that to some file. So I think I already had one. Libc ropper, so you can see I was already ropping around. But yeah, it's good for finding ROP gadgets. I think this tool also integrates with pwndbg. Pwndbg, and pwntools also has its own ROP stuff, but so I think ropper finds more gadgets than pwntools, but both very useful. The next tool is angr. So angr is a symbolic execution engine, and you can use it to dynamically execute binaries and impose constraints, which sounds kind of abstract and nebulous and pointless, but it's actually super useful for auto-solving binaries. So sometimes you'll get like these like license key generator challenges, or you'll get like a binary that just has a bunch of math that you have to do, and you have to figure out what input maps to the output. Kind of boring challenges, but with angr, it's just no thinking is involved. Basically, you'll load the challenge in ghidra, which I'll show next. You'll copy out what the win address is, and you'll copy out some of like the avoid addresses, and you'll tell angr. So this is an angr script. I have a couple of challenges where I used angr already uploaded. I'd recommend checking those out if you want more of an angr tutorial. But you'll create a new project. Here's the binary. You set the base address to 0. You'll create the project. Just a bunch of setup. You set these good addresses and bad addresses, and you say, hey, angr, figure out the set of input or files, or you can massage this, like you can do command line arguments. Figure it out such that we can get to a good address. And angr will just kind of dutifully explore until it can find some set of conditions that get you to the good address. So like I said, a lot of challenges will be like, give me the secret password and I'll give you the flag. And so you just say wherever it prints out the flag, that's the good address you want to get to. You tell angr that, and it'll figure out, under the hood, it's using this tool called Z3. I also almost put Z3 on this list, but I found myself using Z3 less and less. Not because Z3 isn't amazing, but I think it's better just to learn the math now. But angr is just amazing. Like you give it that address, and it'll figure out the correct input that takes you there. And so on the challenges where you can use angr, it's just absolutely free points. It can be a little bit frustrating getting started with angr. I find debugging things can be a little bit frustrating. You can enable a logger. I think I don't remember the exact syntax, but it's like import logging, and then you can do logging.getLogger, or maybe like angr or something, and then you can set the log level. You have to look up the right syntax, but something like that. You can enable the logging on angr, and you can see where it's jumping. I also highly recommend printing out the initial state. This will show you the address of where it's executing, and it should be near where your good addresses and bad addresses are. Sometimes in ghidra, like the base offset will be a little bit different. That's why I set base address here, but like ghidra might, if you're like on a 32-bit machine, it might put a 4 here, or it might put a 1 here on a 64-bit binary. Just making sure you're within like the same address space is useful. But like I said, it just auto-solves challenges. For learning angr, there's a whole bunch of just like, I think if you go to Hacktricks, it has a bunch of examples. The angr website also has a bunch of examples. And then just doing a bunch of reversing challenges and kind of like, build up the intuition. It's super useful. Once you here, I usually just do embed. So this kind of launches you into a Python shell. But you can do sm.found. So that'll be your found state. This is normally how I would print out. This is the POSIX. and dump file 0. So I'm dumping the standard in. So this will tell me what standard in generated the correct case. But you can do a whole bunch of stuff in here. You can add more constraints. So this is the solver, the Z3 solver. Again, you really have to read the docs on this stuff because it is a big tool, but again, it's definitely well worth the time learning how to use it. You can grab memory from it. You can look at the registers. I had a challenge a while ago. It's going to be somewhere on the playlist where you can use angr hooks. So whenever an address is hit, instead of doing whatever it was going to do, you can get it to do something else. I use that as a program counter, so I could like count the number of times a certain function was hit, and then I did some other dynamic stuff in there. Again, just a very versatile tool and very useful. It does take a little bit of time to get used to it though, but once you do, it's like free points on a couple of challenges every CTF. The next tool is ghidra. So this is a disassembly tool, a reversing tool. So you give it your binary and it'll read all the assembly and perform a bunch of analysis on you or on the binary to kind of help you do a bunch of stuff. There's a bunch of related tools. So there's ghidra, there's IDA, there's binary ninja, there's radare. You can just use object dump. There's probably a whole bunch more. I just use ghidra. I think its decompilation works really well. Sometimes it's not perfect. Sometimes I do switch to a different tool. But I think it works really well. It's free. Definitely have no complaints. I think I'm also just used to it. So it's what I use. I'm not married to it. Just it works well. And whenever I poke at the other tools, I think just this decompilation right here just works better than the other tools. But if something changed, like I'm not married to the tool. But anyways, so here's the functions. When I open up a binary, I go over here, look at the different functions, see what they have. This is a very simple binary. This is another one from LACTF. This was Rickroll. I just had it open. So we have the main function. Either there's main or entry. You click on this, and eventually you'll get here. And from here, you can just start renaming variables, giving it the correct type. Usually you use this tool to kind of gain an intuition for what the program's doing. So if it's like a pwn challenge, you're going to try to find where the bug is. If it's a reversing challenge, you're just trying to figure out what crazy shenanigans the challenge author was up to or how they were feeling that day. So you can rename variables. So we'll call this buffer. This is main called. Really, this should be like a full multi-hour video series, just showing you the absolute basics. But you can rename buffers, try to get understanding for things. You can also rename the types. So like right now this is a car buffer, but if we wanted, we could say it's actually a car star. Doesn't really make any sense, but you could. You can also click through, it'll take you to the data section so you can see where this is defined. You can see this is slightly off color, so you can go to the data section, see where other things are. Kind of related to that, you can go to strings. We're going to search for different strings. So we saw never was there. This will take us to where strings is defined, which is here. If we want to, we can also search for a string and see what's using this string. So we can click on this xref, and this will pop up all the places it's being used, which is just right here. Again, very simple binary. A lot of useful stuff. You can also use it to define structs and different objects, which can be very useful for reversing. It also has a big scripting API. To be honest, I haven't investigated too much, but I really should. And yeah, there's a whole bunch of plugins. I think I mentioned earlier I had to do something related to some ESP32 reversing. Someone built a plugin for that, so I just imported the plugin and was reading this code in a very different assembly language. And the reversing worked perfectly. It was very impressed. Yeah, like I said, there's a lot to this tool, but I mean, right there was pretty much 99% of what I use ghidra for. I import the binary. I kind of click through the functions. You can relabel the functions. So this function doesn't do anything too exciting, but if I said this was the encryption function, I relabel it. It's down here. If I want to filter on it, I look for the encryption function. I look at what the program's importing, what it's exporting. Nice and simple, works really well. I don't have any issues with it. The last tool, it's kind of a cop-out, but I feel like everyone says this, but the hacker's favorite tool is Google. If you're not familiar with Google dorking, there's a bunch of specific Google commands that you can use to search for little things. So I don't know why you would want this, but if you were specifically looking for the string Docker hub, it'll search for only this exact string. This could be useful. Actually, a good example would be maybe you're doing an OS int open source intelligence challenge where the flags have a very specific format. And let's say, I don't know, pwn-CTF, something like this. You can use these quote characters to only find pwn-CTF. And so you can see here, this is pwn-CTF. and pwn-CTF. So that's very useful if you want to exclude results. So let's say we don't want lab, this entry right here. You can do -lab to get rid of it. You can also do, I think, in URL. There's also site. There's a bunch of these keywords. It's called Google Dorking if you want to look it up. But very useful tool. Related to this, there's also a website called Hacktricks. For this, again, this is just the category of like resources that are useful for just looking stuff up. Hacktricks, I don't want to go to Hacktricks because they put a lot of ads on their page right now, and I don't want to show the ads, but they have a bunch, I think it has like 200 contributors now of people just kind of like adding content to this collection of pages. And I think you can edit it on GitHub, and it goes to like this Git Books webpage. But again, super useful. It has like specifically when I need things like escaping Python jails, it has a lot of good content. If I'm looking for like, it has a bunch of angr scripts, like just very CTF kind of technical stuff. Like if I need a checklist of things to try, I think Hacktricks is very good. And then the last resource I'll go to is GitHub. Like if I want to look for, I don't know, like some specific way that angr is being used, like angr logging, you know, you can just search and see how everyone else does it. And here's angr logging level, and here we go. So this is how they do it. It's logging.getlogger angr set level. Just super useful if you want to see how, you know, to use a specific piece of functionality or code. Guaranteed, we're definitely not the first person to do anything specifically on a CTF challenge. We're not looking for 0 days, so you know, you can just find someone else's code and kind of modify it for your uses. But anyways, yeah, that is all 12 tools that I really like. There's a whole bunch of tools. Originally, this was 25 tools. I shrunk it down quite a bit. Maybe I'll do another video if people like this stuff, and I'll include the other 12 tools. Or maybe I'll do another one in 6 months and see if any of these tools have changed. But yeah, if you made it this far, thanks for watching, and yeah, see you at the next CTF.